Well, following my last video, I've bitten the bullet and decided to scrap the servo and micro switch arrangement and use an Arduino for switching the rudder servo between an autopilot and radio control. I happen to have this open log board which can be treated as an Arduino, and I was going to use that for this purpose because it's small, and I don't actually like the open log software anyway. But it turned out that it doesn't bring out enough of the pins from the chip in an accessible form, and although I tried to solder something on there, it didn't work. So instead I've used an rudder, which this is a blown up diagram of it, but it has the advantage of bringing out several of the analog pins, several of the digital pins out onto the board so where they're easily accessible. So I've used an rudder as if it were an Arduino Uno. So what I've got is a radio control here with channel 1 PWM signal connected to an rudder here, which is functioning as an Arduino, which drives this relay, and I'm monitoring the state of this relay on a multimeter. So if the rudder servo is connected to the radio control, we have a low resistance and a beep, and if the rudder servo is connected to the autopilot, we have a high resistance and no beep. This pink thing and these wires are only needed for programming the Arduino. So what we've got here is a small Arduino program that reads the length of the PWM signal, averages it over 4 samples, and then tests it to see whether it is at one extreme or the other, and sets the relay pin accordingly. So if we run that, the moment the transmitter is off, if I turn the transmitter on, the PWM signal is about 1500, or it should be 1500. No, I think I've moved that. Yeah, moved the trim control. The PWM signal, the joystick is in the middle, and nothing happens. But if I put it down to a low value, you can hear the beep. Hopefully, hear the beep, which indicates that now the servo is connected to the radio control. And if I move it the other way, it turns itself off. If we temporarily lose reception by turning the transmitter off, it just holds its existing state. Whether it was on, whether it was one way or the other. But if I turn the transmitter off for 10 seconds, it will eventually time out and switch the servo back to the autopilot in the absence of a radio control signal, as you hear there. The other thing I've done is it doesn't pay attention to small differences in the radio control signal. It's got to be less than 1300 milliseconds, the PWM length, or more than 1700 to activate it. When I originally coded this, I just measured the PWM signal and immediately took action upon it, depending on its length. But what I found was that when I turned the transmitter off, occasionally the receiver generated a PWM signal even though I was not sending it anything, presumably because of radio frequency interference on that frequency. So that's why I changed it to take 4 samples of the PWM signal and average them, which results in slightly more stable behavior. Of course, it's obvious that if you turn your own transmitter off, you are exposing the receiver to be taken over by anybody else in the area who happens to have a transmitter on the same frequency, but nothing is perfect. Another problem that I got is that I managed to unstick the servo that was in here, which was araldited to the bottom, but I haven't been able to unstick the micro switch, which is still down in there. And I'm thinking that probably unsticking it will probably break it, but I could possibly leave it in there. There's plenty of room. So I've just got to finish that off and wire it up permanently.